The slope of a line is showing us how it grows over time, and we are always going to look at slope going from left to right across a graph. We can see a positive slope if you drew a little person all the way to the left. They're going up, 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 uphill on a positive slope. On a negative slope, again, drawing them as far left as you can on that line, that little person is now, skateboarding or whatever, whoo, so fast, down the hill. On a negative slope, we're going downhill or we're declining. On a line that has zero slope is going to be an absolutely flat surface, is not going up or down at all. And then we also have lines that will have undefined slope. On an undefined slope, there is just no way to draw the person because they're falling through space. They have nothing to stand on. They can't walk or slide or skateboard. They are just plummeting to their fiery death. So positive, negative, zero, and undefined. The way we calculate slope is rise over run, and that triangle means change in y over our change in x. And if you have just 2 points you're trying to find the slope between, you can do those by just subtracting y2 minus y1 and x2 minus x1 to find your change in y and change in x. If you're looking at a graph, you can just count between 2 points how far it goes up and down and how far it goes left and right. And if you have a table, you can find your change by subtracting 2 y's and 2 x's to see how much it is increasing by. In this one, since we went up by 2 on the y and up by 1 on the x, our slope would be 2 over 1. All right. So we're going to practice just finding slope. First things first, is this positive, negative, zero, or undefined? If we draw our little person on the all the way left, that person is going up, 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 uphill to go across this picture. So this is a positive slope. And then when we're trying to find the slope, we want to look for nice points. So your main concern is looking for spots where it crosses right on a line of the grid. It's not as nice if you're trying to count from right here and you don't know exactly how much that really is. You want to try to count from spots where we know exactly the value. So right here, how it crosses at -6, -1, that's a nice point. And there's a bunch of other nice points. When we find the slope, we're just going to go from one nice point to the next one. And this is a tricky picture, so be careful. Going from that red one I just drew to, let's just say, the next green one. I'm going to go over, look at this, is 2 from -6 to -4. And then up 1 from -1 to 0. This is a very rude graph because the x and the y axes are changing in different amounts. It should really be 1, 2, 3, 4, 5, 6, 7, 8, but they didn't, so we have to stick with what we have. So our slope here is our rise, which is 1, over our run, which is 2. So my up and down value over my left to right value. Now, did I have to pick those 2 points? No, I could have gone from this point to any point on this graph and said, okay, I went from -1 to 3, that was up 4, and from -6 to 2 is over 8. And then I could have said, oh, well, my slope is 4 over 8. Oh, but interesting, when I simplify that, it turns into 1 over 2. So that's my slope on this graph. Looking for nice points here. Before we do that, is this positive, negative, zero, or undefined? It's negative because my little person is skateboarding on down the hill. Whee! We're going to look for some nice points. I see a nice point right here, right here. I have 3 choices. I need to use 2 of them. Doesn't really matter which. Let's go this one, here to here. I'm going down 2 and over 1, 2, 3. Because I was going down, that is my negative value. So my slope is going to be -2 over 3. And now you might say to me oh, Lindsay, but what if I went from here backwards to here? That's totally fine. Watch what happens. I go up 1, 2, 3, 4. and I go now backwards to the left, 1, 2, 3, 4, 5, 6. So my slope is 4 over negative 6, which, if I divided by negative 2 on the top and the bottom, still simplifies out to negative 2 over 3. And that's equal to 2 over negative 3. These are 3 ways to write the exact same number. Okay? Doesn't matter where you put it as long as there's only one negative sign. Negative 2 over negative 3. That's positive 2 over 3. All right, positive, negative, 0, or undefined. This is a negative slope. We're skateboarding down. And using 2 of those points, like they put a dot on this one, but I don't like that one. It's not right on a line, so I'm not going to use it. I'm going to go from here to here. So we're going down 3 over 2. Down 3 over 2. Rise over my run. Positive, negative, 0, or undefined. My little dude is climbing up the hill, so we are positive slope. And they marked 2 nice points. Here's another nice point, and another nice point, and another nice point. Use any ones you want. I'm going to be crazy and use my farthest away ones just for fun. 1, 2, 3, 4 over 4 and up. 1, 2, 3, 4, 5, 6, 7, 8. So my slope is 8 over 4 or 2. All right, positive, negative, 0, or undefined. If I draw my little dude, flat surface. This is a 0 slope. Nothing to do here except say that it's 0. You could, I suppose, pick 2 nice points and count in between them and say, okay, well, it went over 3, but it did not go up or down at all. So it's 0 over 3. Well, guess what that is? It's 0, right? Positive, negative, 0, or undefined. We're falling. This is undefined. We write this as D and E a lot. Does not exist. Or you can also write undefined. There is no other thing. No numbers involved here. Because we'll note if we took 2 points, we went down 2, and then we did not go left or right at all. So it's over 0. And look out, look out, look out. You do not want to divide by 0. It breaks things. So we just say it's undefined, okay? Straight up and down lines, undefined slope, or D and E does not exist. Oh, sorry, one more. The slope does not exist. There is an equation for this line, and we'll talk about it. When we're comparing slope, the steeper the line, the bigger the slope. So see how this green one is like a steeper, again, thinking about my little dude climbing up it. It's a steeper climb. This one's not so steep. Bigger slope is a steeper line. All right, when you have an equation, if it's in the form y equals mx plus b, where m is any old number and b is any old number, m is the slope of my line and b is the y-intercept of my line. So we love when equations are in y equals form because it just gives me the slope. It's sitting right there. It's 3. Don't have to do anything else with it. I'm done. I even know the y-intercept is 5, so I could start at 5 to graph this. So nice. I have it in y equals form again. Here's the slope. Slope is 1/2. Done. So easy. Now, when it's in standard form, it's a little bit trickier. I just rearrange it into y equals form because I like y equals form better. So we start with our equation and we get y all by itself on one side. So we're trying to isolate that variable. We're going to subtract 3x. Careful, I put those underneath each other, but 13 and 3x cannot be combined. One has an x and one is just a constant. So we can either write this as 13 minus 3x, or we could write it as negative 3x plus 13. I'm doing that way this time just because I want it to be mx plus b, but we'll see as we go on that you don't have to write it that way. All right, now I'm going to be lazy and say negative 3/4 x plus 13/4. And now what's the slope? It's the m. It's whichever number is multiplied by x. So my slope in this one is negative 3/4. We're going to practice that. Don't worry. All right. Getting y all by itself on one side. We're going to subtract 3x on both sides. This time I will just leave it as 18 minus 3x instead of rearranging it. See if that is more or less confusing. To get y all by itself, we're going to divide by 2, divide by 2, divide by 2. And we're going to end up with y equals 9 minus 3 over 2x. So now we've got to be careful. What is the slope? It is whatever's being multiplied by x. So it's going to be, don't lose the minus, negative 3/2. It's that whole thing. That's my slope right there. 9 is my y-intercept. So nice. Okay, getting y all by itself. Let's subtract this x to move it. We've got negative 3y equals negative x plus 5. I'm rearranging it in my head before I even did it. Sorry. Divide by negative 3, divide by negative 3. And what have we got here? Remember there's like that invisible 1 in front of any x or y that's kind of just out there in space. So negative 1 divided by negative 3 is positive 1/3 x minus whatever 5 over 3 is. Which number is my slope? It's the one on x, so it should be positive 1/3. That's how you find slope from an equation. Now, you might see some trickier equations. You're like, this is in y equals form, Lindsay, but what number is on the x? Well, what a great question. I'm so glad you asked. There are, you will note, 0 x's here. So we could write this as 0x plus 4. And if we do that, blam, the slope is 0. Or we can also remember that on a graph, y equals 4 is a horizontal line, always. Y equals number is always going to be a horizontal line. And horizontal lines always have a slope of 0. Notice 4 is my y-intercept. How lovely. When you have the other weirdo, an x equals a number. Remember, if it was in y equals mx plus b, then this number here would be the slope. But there isn't even a y like anywhere in this problem. So we certainly can't get it into y equals form. So this is our undefined or DNE slope. There is just no way to do it. And remember, on a graph, an x equals a number line is a straight up and down vertical line that has no slope, undefined, not a 0 slope. It is just, there's no slope to it. It does not exist. So anytime you have x equals a number, the slope is undefined or does not exist. All right, you will be asked to find the slope just from 2 points. And that's when we're going to come back to using this formula from the very first slide, rise over run. So we're going to take our points and say, remembering it's always x first and then y, x first and then y. And then we can pick, really, it doesn't matter which ones are 1 and which ones are 2 as long as you keep them together, right? So I'm going to do, let's do some color coding. Oh, I did not. Well, the first one will be red. That's fine. 16 minus 10. Sorry, I'm going to put all my things in. There we go. And negative 6 minus 18. That's my problem to solve right there. So we're going to do 16 minus 10 is 6. Negative 6 minus 18 is negative 24. And then we want to always make sure we simplify our slope if we can. I could certainly take 2 out of this. And then I could take 3 out of this. It's going to be 1 over negative 4. Or you could have had negative 1 over 4. Doesn't matter. All that matters is, notice how 16 and negative 6 are together. They should be together, like above each other in the equation, and 18 and 10 similar. And y's on the top, x's on the bottom. Let's practice. So we have got negative 14, 20. Oh, shouldn't have used yellow. I'm going to change it already. 17, and 19. So we need to go between negative 14, 20 and positive 17, 19. So we're going to subtract y2 minus y1. Oh, minus over minus. There we go. I guess we're sticking with yellow. Sorry about it. Y2 minus 20, 19 minus 20, and 17 minus my negative 14. All right, so when I solve this, 19 minus 20 is negative 1. And then careful, 17 minus negative 14 turns into 17 plus 14. So this is going to become negative 1 over, 31. Very odd slope, but here we are. All right, stick with me without color coding if you can. X1, Y1, X2, Y2. We're going to subtract our Y's. And just to be difficult, I'm going to do Y1 minus Y2 this time. So I'm going to go 3 minus negative 9. Since I used 3 first this time, I have to use negative 8 first on the bottom. Negative 8 minus 1. All right, negative 3 minus negative 9 turns into, 3 minus negative 9 turns into 3 plus 9. And negative 8 minus 1 turns into negative 9. Let's go ahead and add that top. 12 over negative 9. And now I can divide out 3 to make this 4 over negative 3.